Hi, I think good afternoon and good evening for people who have joined across the world. Welcome to our second Agentic webinar. This time, again, myself and Karthik are doing it. We will also give a short introduction. Um, the 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 topic for today is Agentic AI patterns. We will discuss that in detail. And we also have a small surprise. We ran a hackathon last week at that organization, and the winner of the hackathon's team is represented by Syed. He's also going to present a product which is live in production in our ecosystem, which we'll be using for our own purposes as well. Right. With this, Nagaraj, you want to say something before you give it back to us?
Yeah, the same thing as we have seen more in interest in the previous agentic AI webinar. So as a part of continuations to that, we are attending this session that will explore into more agentic AIs with the real-time demos as Vinny said, we are having a surprise that is hackathon demonstration from our team. So over to you, Vinith and Karthik.
Yeah. I'll give a quick introduction of myself for those who don't know me and have joined this call. My name is Vineet. I've got about 20 years of experience, predominantly including C++, low code, and AI. I'm ex-Microsoft. I've led AI business solutions for Microsoft, and I actively work with the customers across in Netherlands, also in other parts on agentic advisory and implementations. I have Karthik with me. Karthik, you want to give a small introduction yourself? Yeah.
Hey everybody, I'm Karthik, head of AI in FusionX. I come from a sciences background. I've worked in various fields, including GovTech and in the insurance space and several other domains. In the past couple of years, Vineet and I have been really deep into this agentic AI zone. And I think we're eager to show where the kind of possibilities we have already unlocked, and happy to show what we have for us with you.
Yeah. Just before, I just want to check, are you all able to see my presentation? I hope so. You can. If you can, just put that in the chat that you can. Yeah, Bo's already said so. So that's great. I'm going to start talking through it. What I want to do slightly different here is, a bit of conversation along with Karthik. We are a bunch of highly enthusiastic people on AI. We're a group of ex-Microsoft, ex-Google, and also IITians in this call who are able to quickly understand different patterns, also able to help our customers build them on their agentic journey, right? So today's topic, which we wanted to go through, is AI agentic design patterns. And in this particular session, I wanted to go a step further. So we already had some ready-made demos, but I asked Karthik if you can show something live getting built in for each pattern. That'll be amazing, right? I think Karthik did try his best. Maybe he should be able to show. If not, we have a backup plan where we have already some agents which are in productions using some of these patterns. We should be able to show you. Okay, so what makes AI agents different from the traditional system, right? So I think I spoke about this briefly in our past webinar, that the whole agentic revolution started from how in the past conversations used to happen with, let's say, a small bot, and then agent kind of became the fallback of that whole conversation, right? And it became conversational AI, then it became autonomous AI and those kind of stuff, right? Now, there are 5 core components of the specific capabilities when you speak about AI. That is autonomy, with whether that is taking goal-directed actions with minimum oversight, making independent decisions to achieve objectives. Then there is reasoning, which engages in contextual decision making. Then is adaptive planning and language understanding. Language understanding is quite important as well, whether that is autonomous or conversational in nature, right? And you'll see that 33% enterprise adoption by 2028. Some of the critical challenges: balancing autonomy, right, with predictability, having a predictable outcome is very important when you build agentic platforms. Ensuring system transparency, explainability, full auditability, so you're able to monitor and govern them much better, and maintaining robust security and privacy controls over agents, right? And guaranteeing no bias and fairness, right? Uh, I also want to let you know that the next webinar session is securing on agentic landscape, both on your enterprise platform. We're going to give an example on Copilot as well as on Pega. So you'll get a fair understanding of how can you do red, green, zone, amber techniques, and also do some policies to secure agentic platforms. So with that, I want to start with the agentic architectural foundation first. And I want to speak about the 5 components in this, right? Like in the past, we spoke about agent has got a persona, and the persona basically defines what the agent does, right? So it's got the most important thing is the model itself, which is the LLM. It could be it's the core reasoning engine. It could also run the orchestration. There is an instruction and policy. There are a bunch of tools. There's an orchestration, workflow management, and observability. So these are the core components which essentially makes those whole agents, right? Now, I have a questions. Karthik is in the call, and I wanted to make it a little more conversational. I understand his point of view. Why do you think, Karthik, that so the patterns which we are going to discuss, these are quite enterprise patterns, which is quite research, right? Why do you think these patterns, understanding patterns and implementing these patterns are more critical than going and researching your own pattern and building it, right? What do you think, or your recommendation would be for the public which have joined for this call?
Well, the answer is almost in the question there, because a tried and tested pattern is a template on which development can be made. Trying to come up with a workflow on our own. So the patterns, many of them are intuitive in nature. So you have got the kind of coordinator and the validation, the kind of checks we require. If you're going through a multi-agent framework to answer a particular question, or you're doing a group chat orchestration or anything of this nature, you want the conversation to flow in a particular way, or the orchestration to flow in a particular way, so that you get the results that you desire. So more often than not, these are patterns that are that makes sense intuitively to communicate and build upon without reinventing the wheel every time. I think, and I wonder how you feel about that.
Yeah, I think
Have
I
you
totally agree.
tried doing like completely new orchestration
Yeah, I mean,
frameworks of that nature?
so see, look, these are properly researched architecture which is working in the industry, right? So, Victor has written a right book about it, and he's also experimented with most of the patterns, right? So I believe in the agentic world, the speed is very critical, right? So understanding these patterns and then using the existing patterns, maybe slightly deviate or customize, and then quickly deliver is the objective. If you start thinking of without the pattern knowledge, if you start implementing, it gets a bit difficult to build the framework, validate the framework, and then go live. So you can say, hey, these are the set of 4 or 5 patterns approved in my organization. So any design architecture which is coming in these patterns, it should be easy to go, right? So I think it is critical to really understand those patterns and then build expertise around those patterns in your organization.
Sure.
So choosing the right complexity level for your use case, in the agentic architecture, it's important that whether you're creating a direct model call or you're doing a single agent with tools or you're doing multi-agent, you got to understand what is fit for what, right? For example, if you're doing a direct model call, this is a single LLM with a prompt. So classification, summarization, translations, all these kind of stuffs work pretty easy with this, right? So you don't need an agentic persona for that. If you have certain tools which will execute certain tasks, so you could do probably a single agent with tools, with one agent with the tool access, which could do that, right? There's a multi-agent orchestration where you need to respect the cross-domain boundaries. So if the boundaries comes into picture, you can have multi-agent orchestrations, which could just take care of that. So you have to keep in mind with these examples, some of the use cases which could direct you towards whether I'm doing a direct model call or a single agent tools or a multi-agent orchestration to define thinking about your use case optimization using agentic architecture, right? In this architecture, The first one is sequential orchestration, right? Now, this is fairly simple. But it chains agents in a preferred linear workflow where each agent process inputs from the previous one. So if I have three agents, the agent A is a kind of giving an output for the agent B, and then thereafter C is also waiting for an output. So they are sequential in nature, and each other depend on that, right? So each agent performs a specific transformation or refinement step before passing the result to the next one. These are ideal for workflows with clear dependencies and progressive refinement steps, where pipes and filters design pattern can be powered by agents, right? And fixed handoff rather than dynamic collaboration, and provide predictable execution model for enterprise automation scenarios, right? Take a small example. Look at this example where there is no dependencies. There are dependencies such, that's why they're sequential in nature. So document creation requirements, there is a template selection agent which looks at its knowledge to get the particular model template. Then it goes to clause customization, which is a fine-tuned model specifically doing customization on the clauses. Then there is a regulatory compliance agent, which is looking at all these template and the clause, passing into regulatory compliance and making sure that it is compliant according to that. Then it is finally going to the risk assessment agent, which is looking at all the risk on these documents created, and then the final document is generated. So you can see that they're actually sequential in nature, and they're waiting for each other to proceed, right? Now, uh, I probably will request Karthik to do probably a live one. If you have want to do an example here, Karthik.
Oh yes. For this is for the okay. I can. Till where do you want me to do it for now?
So I think
Which
let's
modes do you want
do
me to
this
show?
more efficient. So what I'm going to do is I am going to run through a couple of um, um, patterns, and then we can do it together. Maybe that's more efficient, I feel, right?
Let's do that.
Yeah.
Yes.
So I think so. The sequential pattern is fairly simple. You can still see my screen, right? I'm just confirming. Yeah.
Yes.
Yeah. So it's simple. It goes in this execution. Then there is concurrent pattern, wherein concurrent orchestration happens, and this is typically 3 times faster task completion with compared to parallel execution of agent, right? So these are agents which can concurrently execute a task, and then they can perform parallelly to execute something. So they don't have dependencies on each other, and they can spin off and then do a particular task, right? So you can see multiple agents operate independently in parallel, each offering specialized insights or actions without passing results between them. They have a fan out and fan in architectural style aggregates diverse outputs from parallel agents. They boost efficiency and diversity of output by leveraging multiple specialized perspectives simultaneously on the same problem. And each agent tackles tasks from a different angle, reducing overall processing time compared to the sequential workflow, right? So if you look at an example of this, if I go next, so I have a ticker symbol, and it is looking at a stock analysis agent. The moment the stock analysis agent with its persona, that is model exchange, symbol mapping knowledge, it needs to decision with supporting evidence based on combined intermediate results. So what it does is it spins off fundamental analysis agent, technical analysis agent, sentiment analysis agent, and ESC agent, all parallelly, which have their own respective fine-tuned models and market intelligence to compute fundamental analysis, technical analysis, and sentiment analysis, and they give their intermediate results, which goes back to the stock analysis, and they give the final conclusion of what needs to be done. So fundamental analysis and technical analysis are not dependent on each other. That is why we were able to execute a particular concurrency in this pattern itself, right? This pattern is highly efficient. It only works if there is no dependency between the agents to be run in parallel. Okay, now this is an interesting one. There's another one known as group chat orchestration, right? And I have a very nice demo of it as well. But Karthik is going to code right in front of you to show you in a more intuitive way, right? But I also plan to show you what I built myself as well. Um, these are specialized agent or domain specific agents, human in the loop, and some shared context agents. They are collaborating between each other to execute a task, right? So in this architecture, what happens? There is a group chat controller. The group chat controller's agent's job is to execute the whole chat between the orchestration of this agent. So imagine there is an agent A, agent B. The group chat manager can tell, hey, agent A, you talk to agent B in a feedback mechanism, but talk in iteration of 5. So what it will do, agent A's output is going to agent B. Agent B analyzes it and sends it back for A saying that I did not like your output, go fix it, right? And he can control the time it can do the chats between each other, right? So it's ideal for decision making and validation, which requires multiple experts. And this is where a maker, checker, a codex kind of a stuff works, because in this there is a master, a moderator, which is moderating between the agents to execute that task, right? They engage in a dynamic discussion and building in each other's contribution to research consensus and comprehensive solution. I think I was talking to Karthik about this. I don't know if he's going to show it today, but he built a very cool moderator-based agency system where they're playing chess to each other, right? So there is a moderator which is controlling two other agents which are playing chess to each other and trying to win. So that's also a pretty cool example of how the group chat could work between the agents. So this is an example of a park development proposal. There is a group chat manager. So there is a community engagement model, and there's an environment planning agent model and the park budget agent, right? Now, what the group chat manager is doing is it's trying to make a chat between three agents and then get the final output. And that conversation is gone to as a park proposal consensus. So you can build your agents in similar fashion and then execute it, right? So I think I build I think I had a demo of this small one. Maybe I can share my screen and show that as well. But keep in mind, Karthik's demos are way cooler than mine. But I wanted to show you probably mine as well. Give me a moment. Yeah. So I'm going to share my screen back again. So here, if you look at, there is a multi-agent orchestration happening. What is happening is there are 4 different agents, and 2 of them are reusable assets, and two of them are specific task execution. But there is a chat happening between the agentic HR specialist agent and the external communication agent for 4 times before making that conclusion. So if you see on my demo part, if I go here and play this, you'll see that there are 2 agents. They are actually talking to each other. The agent 2 has created the summarization, and the summarization will go to agent 3, and agent 3 will give a feedback whether the agent 3 is liking that summarization or not, right? So you'll see here, agent 2 is now creating the job requisition with the knowledge tag, and then it is going to agent 3, which is basically yeah, it's still creating that stuff. And see, agent 3 is coming up in the picture. Agent 3 is doing a communication between the agents. So interaction 1, it goes and say, hey, I didn't like the logo is wrong, go fix it. I didn't like the grammar. Then it does the interaction 2. When it came back again after fixing, it's doing again, I didn't like these parts. There's no consistent facing, ensure universal accessibility. It does that chat for 5 times until it is satisfied. And once it is satisfied, it actually makes an exit and then goes and does that particular consensus for the final execution, right? So that's pretty much how that group chat kind of concept works, right? So it's a pretty interesting concept, and I really love how that's taken care, right? And there's also handoff orchestration where, when you're trying to work with agents, the handoff could go to a different task specific agent or a handoff specific to a human entity as well, right? So each agent evaluates whether the handle task or pass control to more appropriate specialized agent in evaluating context, right? So this is basically, I got the task, but I feel this is something which I shouldn't do it. So it's handing off to somebody else. So it's also looking at, hey, the planner ran something, but I got a task, but it doesn't look like I have the skills to do it. But I know somebody in my loop who has the skills, so I'm going to hand off, right? So it's very dynamic delegation of tasks, and then it comes back. So this is a typical example of how the customer support employee is getting a handoff from the triad support agent. It actually went to financial support. It went here, and then it finally hand off to a customer support, right? So this typically could happen also in a customer service behavior when you're building agents, that you called up for a credit card, you got connected to somebody else or a different domain specific, and then the handoff happened to the right person. Or none of the agents could figure it out, and then the human analyst is actually talking to you and then doing. In reality, most of the banks, if you talk to their conversational AI at the moment, you'll see you will hardly get connected to a human because they are so efficient in making these executions themselves, right? Then one of my favorite architecture is Magentic orchestration. You need advanced skills and capability to execute this. And this is basically a task ledger between the specialized agent to execute a task, right? So what the Magentic orchestration does is you give it a task. Hey, go do this task. What the Magentic orchestration will do, it'll create a ledger of tasks. It'll say, hey, I will do the task, but I will create this task in a specific order, in a sequence, and I'll ask the human in the loop, hey, are you interested to run this in this specific order, or do you have any inputs for me? So the planned ledger is presented to the human and then finally executed as well. It's one of the most brilliant architectures. I think we already use this in our Agentic AI studio. So if I can show that demo once Karthik shows his demos. We also use this in our RFP agent where there is Magentic planner ledger bringing the human in the loop and then executing the plan and also making the human part of the plan, right? These are very intelligent way of doing it. There's also a Magentic UI pattern available. SDK, you can download that and experiment yourself. So you can say this is a dynamic orchestration or a task ledger based orchestration where a manager agent is creating a task and progress ledger and is getting the human in the loop and then calling agent one, agent two, agent three, depending on the way the task has to be executed on the ledger, right? So it's the agent is not executing how it wants. Agentic is presenting the plan to the human saying that, hey, I want to execute in this way. Do you want me to execute in this way or do you want me to change it? So in our agentic studio, if you say, hey, go and create a ticket, it'll actually tell you, hey, I'm going to do this with service now and blah, blah, blah. But you can also change step number 3 to step number 2, step number 2 to 3, and you can execute that however you wish to do. So this is always human in control and human on control as well. So you can do both of them in tandem, right? I will take a break here because choosing the right pattern. We'll come back and speak along with Karthik. But I wanted Karthik to show some of the cool demos. There are some recorded demos, but I wanted to make it more fun. So I gave a live example. Well, I forced Karthik to create live examples. So what he's gonna show now is what he built another last 10 minutes to show you these patterns right now. Over to you, Karthik.
Yeah, I think this should be fun. It's always good to see it at a conceptual level, but to also see it in action, to see qualitatively how the response feels like is always a good thing to know. So let's do something to that effect. So for instance, let's take the same single incident description. So the use case that we're looking at is some sort of a customer is reporting that the finance department cannot access billing portal after SSO migration. So there is a dummy AI search that is powering it in the backend. A bunch of simple knowledge-based things have been indexed and stored at the backend, and that serves as a means to answer a query like this. So what do we do about this? So let's take the direct call approach and just run it. So basically now it says, it just sort of assigns a sort of criticality to it. It says the user is the finance department unable to access, etc., etc. Issue is preventing critical monthly. And so it sort of, this is a very simple thing. It just sort of contextualizes what is being provided here and adds as a way to assign a certain degree of criticality to it. So you have a suggested response, the summary. So this acts like a co-pilot to an actual person who is using it. So it also gives you a sort of suggested response with a summary to create a ticket. A single agent is a slightly better version. It is also, I mean, the direct call is simply an answer to the query. The single agent, the only step above it is it has a RAG associated with it. So it's able to look into the knowledge base and have a slightly better, suggested resolution based on the knowledge base that we have there. So we've got stuff like, it looks up the account, check services, a bunch of tool calls are done, but also in done it is a single account, and it sort of gives you a slightly better understanding of what might be going on and enriches the response a little bit further. Go by it in the sequential route. Sequential takes long. It sort of makes the case for why concurrent works well. Uh, yes. So here we have a situation where we have a pipeline. So we have a triage pipeline, an investigation pipeline, and a resolution pipeline. So there are three agents acting one after the other. I just built up a small AI. I think doing the same thing through a smoke test will give you a little bit better understanding of what happens within it. I mean, for those of you who are a little bit more, JSON habituated. But this is, qualitatively, it works a little bit better. It works through the, it sort of gives, the LLM responses at each stage. So the first agent provides this, it summarizes it. Then the second agent adds a little bit more, understands, performs triage. Second agent performs an investigation. And the third agent suggests a resolution, basically. So all three of them, there are three agents, all of which provide the response and give a slightly more sophisticated output. Now, this thing can, in some cases, be made concurrent as well. This one typically works way faster. Yes, in this case, it's like, okay, we sort of look at it from a different specialist analyses come in simultaneously. So we have the specialist responses coming, right now I just implemented one specialist here. And there's a manager kind of thing that sort of, this, we have separated it out between two agents, synthesizes the two of them and provides the answer back. So here we have the risk level being critical, then we have the findings and the recommendations coming in this. I mean, we get a combined recommendation here. The difference here is that we have a little bit of enhancement in speed, and especially when agents don't need to rely on the results of a prior agent, it works pretty well. The group chat is the. Shall I do the group chat now, or do you want to get into a little bit of, talk into the group chat
Yeah, I think
implementation?
the group chat one I showed a sample with mine as well, so we can do it later as well. I think, but I think public got the idea about what a group chat is already, right?
Okay, I've run it anyway. It just takes about 90 seconds to run. That's why
Yeah, let's
I
wait
asked the
for it and
question.
see it, because I think it's more fun when we see something live, right? And something that's recorded, people think that we're prepared for this. I just want to ensure that
Absolutely.
there was no preparation on this. This is built right in front of you in the last 10 minutes.
Yes, yes. And even within this, there is, because every time an agent, each of these agents that have been implemented here, the SRE, the commander agent, I call it the commander, the coordinator agent, and, the investigator and the security team, all of it, they sort of pass messages among each other. So under the hood, there's a whole bunch of conversation that's happening here, which has been logged in this kind of form. So the first one, as incident command, I'll start by framing the incident and so on. This passes it on. Okay, both the billing report healthy services, healthy status with no outages. This is sort of a, it looks up, the status with a tool call to see whether a particular, whether the service is actually down or not. So it can actually perform, an informed triage, not just provide advisory, but can actually look up the status of certain services. So suppose you've got a health check endpoint for an API, it can just run that and come back. So it can decide certain things to do. And there's also a security agent. So there's an identity admin. All these personas exist, and all of them pass messages among each other, basically. So the SRE has a report, and then the identity admin comes up with another report saying that we can likely rule out outages. The security analyst raises another point. So there's another, they all sort of have what seems like a human-like conversation. And at the end of all of these conversations, we have, I mean, I put in a hard block at the 10th message so that they don't just talk among each other continuously. So the identity admin, the security engineer, support lead, etc., are being pinged. These are the human personae, and asking them to ping with the response with, it's a call for additional information. So when it sort of ends at the last message, rather than end abruptly saying there is an intermediate stage, it says what further information could help in resolving this. And at that point, the identity admin is asked for some confirmation on certain things. The security engineer is asked for a confirmation on certain things. The support lead is asked for some confirmation on some other things, and a classification and a summary of the whole, incident happens here. And effectively, this through this kind of group chat with each persona having access to different tools, one having access to maybe a health check and so on, you can actually come up with a much more detailed way of error handling and rather root cause finding and so on, and come up with the best possible report, and have a perfectly engineered response here. So you've got a effectively at the end of all of this, you've got the billing account in. So it's the same question. So we have made a long journey from the single agent thing, which is just a basic tool call, all the way to multiple agents, each having their own specializations, talking to each other, coming up with, and then one commander sort of cutting through the BS basically and coming to a resolution as much as possible. And the incident commander, SRE, and security analysts are all participating in this conversation here.
Yeah. One
So
question I
this
have for you, Karthik. I think it's
Mhm.
brilliant that you were able to show this live, and we'll also show our own demos, what we build internally, which we're using. I have a favorite framework. I use semantic kernel, or now it's known as Azure Agentic framework. Do you have a favorite framework where you like to build Magentic, or let's
uh,
say the group chat one?
precise. I used the successor to semantic kernel here. It is a Microsoft Agent framework,
Yeah.
which has been built by Microsoft as they are sort of retiring semantic kernel and promoting agent framework here. So the Microsoft Agent framework SDK for Python is
It's
my
great, right?
go-to choice for some of these things, and that's what's been implemented here as well.
Yeah, I think my main also. And do you have any favorite books? Like, because I quoted Victor, who's from Microsoft Research. He wrote all the semantic kernel. I read his book. His patterns are lovely. Do you have any favorites there as well?
I am more of a Microsoft Learn kind of guy. I've become completely hooked to using those documentations. But yes, I mean, that sounds like a great resource. I really
By
should
the
be
way, they
going
have
to.
a MCP as well on the learner. You can connect to the MCP and also ask, hey, go and learn and come back and build this as well, right?
Yeah, that
Yeah.
sounds that no, I really should do that.
Yeah.
Yes. So,
Great.
in fact, you can see this. The group chat is the
The
orchestrations
semantic
group
kernel, yeah,
chat
it's
builder
from,
has been
I
used
think
here.
this is the AutoGen framework, which was later converted into, yeah. Yeah.
Precisely. So the patterns will likely look very similar to you.
Amazing. Um, since you are sharing the screen, should we show them the Magentic pattern which Syed built, or should we show them the AI studio? I'm.
Probably
Oh, you have the
both if we
Magentic
have the
pattern here
time for it.
because yeah, let's do that. I mean, if you can, I don't have Syed's video. Maybe you can show Syed's video, and then I can show the AI studio because I have that open already.
Okay, sounds good. I
Yeah.
did the Magentic pattern too, which also is enabled by, there's a Magentic builder in Agent
Mhm.
Framework orchestrations. So I used that for this as well.
Yeah,
So there's a
I think
manager in
Magentic is my favorite. Like if I am speaking to somebody from the AI
analyst, you
world
get
and I
the
say,
impact
yeah, if I
analyst, or the 4%.
yeah, like usually if I'm speaking to somebody who says I know a lot of AI and agentic, and I ask them, do you have you built a agentic? And they say no, it's like, okay, this guy is not explored it enough, right? So yeah.
Yeah, Magentic is, well, quite majestic, actually.
Yeah. Okay, let's
Mm,
see this video then, because I think we have 10 more minutes before we hand off to Syed.
let's do that because this usually takes about 90 seconds to
Okay,
run. I
so
think we're halfway through. Maybe give it another 30 seconds, and then
okay,
let's
then
just
let's do that.
move
Yeah.
on.
Any questions? Meanwhile, I think I also see. Thanks, Kamil. That's the framework. That's correct. It is a successor of semantic kernel and AutoGen. I think there is no other frame which is even close to it. This is one of the best frameworks which you can use to build all these things. And the best part is it all works on GitHub Copilot. So if you have a GitHub Copilot and you love Visual Studio, just put that and then it starts working. Okay, so maybe it's still running. Maybe I can show my screen until it runs and then, okay, is it run already?
Yeah, but here the detailed analysis is not shown here, but it will be
Yeah, I
shown in
think.
the smoke test.
Let me share my screen meanwhile.
Yes, I'll stop.
Yeah, so I think what I want to show you is first is an RFP agent, which we internally use as our product. We don't sell it. We use it internally. And this is a multi-agent system where there's human in the loop. I'm going to quickly just run through. RFPs are automatically extracted. It's got multi-agents which identify requirements, build queries, and generate responses. And each one of them are sending inputs to each other, right? So if you can see on the right-hand side, they're reading the inputs. They're actually presenting the options to the human. And then finally, when they all finish their stuff, we confirm the build query, and then it goes and generates the whole RFP back, right? So this is a nice example how all multi-agents are working together with human in the loop and execute something brilliant, right? And this is something which we use internally for our RFP responses. Then we built an AI studio. I call it like a cheap replica of what is that? That MoveWorks, right? This uses a Magentic pattern. So you can see there is, if you when you give a task, it presents a step, and the steps could be changed. So you can also say, hey, I don't like your plan, go change the plan or accept the plan. And the plan is then executed on behalf of you in the Magentic pattern, right? And this is where computers and human really work in tandem to do something, right? So this is not like, hey, you are completely in control and computer is giving you really nice plan to execute something, right? So here in this AI studio, you can create your own agents which follow the Magentic pattern to execute stuff. So you can see here there's a step one, step two, step three, and there this is actually connected to service now, I think. And then it basically, so you can see it's creating the ticket as well. So it's basically making you part of the plan and then executing that as well. Um, I'll I will give it back to Karthik because I think Karthik could show some more of examples of Magentic patterns, and any other video you wish to share, Karthik.
Yeah, I think as far as the Magentic thing is concerned, I have put it with some automated, I mean, the replanning function, I've sort of hard coded some of the replan possibilities there. So, for example, it's the same input query. The customer account 001 reports cascading failure and billing port is down, etc., etc., and business impact and so on. And multiple services, we need a coordinated investigation across infrastructure, security, and business impact. So this is the query that comes in, which is used GPT 4.1 mini, and then it starts the incident manager, and then the participants are the infra investigator, security investigator, and impact analyst. So the first thing is like, okay, it just figures out, it gives you a sense of what could be the possible root causes, and it gives you a plan of, check for misconfigured SAML assertions and so on and so forth. And then the second one sort of emulates the flow. It says health, all report is healthy, no issues, etc., etc. And the HTTP may caused by transit issue, etc., etc. And then this is what the first response comes out to be. And the other agent also comes up with a response to the identity manager, and it sort of comes up with understand, it again tries to come back with a request for specific logs here. So it again goes into providing the location, etc., etc. Now then it says, in the fifth message, it goes back into saying what does it require to actually answer this problem. So this, when you plan a particular solution to a task, it's very similar even here. So you keep revisiting this idea. So it's a combination of the kind of Magentic pattern and the group chat pattern here.
Yeah,
So
lovely.
there's a plan as well as once to execute the plan, there are the other agents that sort of come into the picture and perform
Yeah.
the requisite analysis on that. And
Thanks,
yeah, there
Karthik.
we
Just
go. And at the
considering
end of
time.
all of this, we get this.
Yeah, I wanted to hijack it back because we need to give time to Sayed as well as questions. Thank you so much.
Oh, yeah,
I
absolutely.
don't love to put you in under pressure, but whenever I do, you always come with something genius. So thanks for this. I'm going to go back to my agentic pattern to just round it up. Choosing the right pattern, use lowest complexity level that reliably meets your requirement. Each pattern's add coordination overhead, latency, and cost. So you have to think really well, cost and performance to make that call, right? Sequential fixed workflows, concurrent parallel processing, and group chat collaborative decisions. Advanced patterns, Magentic you have to be really confident on this and then bring them in your organization, right? With that, I want to take a break, give 5 minutes for questions, which anybody wants to answer. Please raise your hand. We love to answer that in this 5 minutes window. And then I'm going to give our hackathon winner team to present what they build, which is being live put into a production for our public, employees to use. Hey, questions? I think Nagaraju, maybe you can moderate that. Yeah. Yeah. Yeah, I think nobody has any questions. Looks like it went above everybody's head, or it was probably understood really well. But I think we did explain all the patterns quite well. We had live examples, and Karthik was also able to code live in front of you. And we also gave some suggestion on when to use sport. So pretty good landscape covered there. The next session is going to be securing your agentic landscape, which is an important aspect for all these enterprise architects. How do you really control all this thing? I think Piyush has got a question. No, okay, you hand off. If no questions, I think it's best we transfer this to Syed now. Syed is our head of delivery, and he ran a small team. He mentored a small team, part of our hackathon, which ran for 1 week. And I mean, there were many winners, but I think they got additional points because they could go live immediately on our ecosystem as well, right? Over to you, Sayed, for you to explain what you guys built.
Thanks, Vinit. Thanks. Hi all. Let me share my screen. Hope my screen is visible.
Yeah.
Okay, yeah. So yeah, let me introduce to you all our solution. It's called Cervexa. It's a single window integrated service management Copilot Studio agent, which we have deployed inside Microsoft Teams for all our Fusion X employees. Yeah, the idea behind it is simple. Like for example, today, if an employee has a question or wants to report some issues, what they have to do is they have to try to find out the correct portal uh, to find out the information. Yeah, they have to navigate through menus and different forms. Yeah, if they are unable to find the solutions, they usually raise the request in the different backend systems. Uh, yeah, so to solve it, so what Cervexa does is, so for any of these, an employee can just simply message in Teams. Then this Cervexa agent takes care of answering the queries or triaging the issue and providing suggestions before creating any tickets in the backend. So the main thing which we want to do is reduce the number of tickets which might get created in the backend. So yeah, that's the main purpose of this agent. Let me quickly show you how this multi-agent flow works. So an employee, as I mentioned, so this agent is available in Microsoft Teams. Employee, if he has a query or a issue to report, so they will message to that agent. Then within that agent, we have different agents which we have configured. So based on the details or the question raised by the employee, for example, the classify agent, it uh, goes through it and categorizes the issue, its priority. Then the knowledge agent, it searches our internal knowledge base articles, and based on it, it will provide suggestions or fixes. Yeah, ideally we expect the issue to be resolved or the question to be answered by the knowledge agent. let's say if the employee is still not satisfied with those answers, then we have the diagnose agent. It asks, so again, all the data is fed into the individual agents. So it asks smart questions based on the details already captured by all the other agents. And based on that, then based based on those questions, it provides some suggestions. Then the suggestion agent actually shares, let's say, 2 or 3 suggestions to the user. Yeah, again, we expect it to be resolved here. But yeah, there can be some cases where a IT support or a HR needs to look into it. So yeah, ideally, so in this case, what will happen is usually we can just provide a link to the portal where they can go and raise the ticket. But what this agent does is it doesn't let the employee leave the team chat. So here what we have done is we have used Azure functions. What it does is, yeah, it again does intelligently. So if it is network issues, what it will do is it will call ServiceNow API. And yeah, ServiceNow, it takes the ServiceNow API's UI metadata and converts it into adaptive card JSON so that the ServiceNow's screen or the form gets displayed directly in the Teams. Yeah, it's the same with the Pega backend system as well. So the Pega's DX API returns the UI metadata, right? So this Azure function basically acts as an interpreter to convert that Pega UI metadata into Microsoft Adaptive Card and shows the UI directly in the Teams chat. Yeah, let me now show you the demo quickly. Yeah, so this is our this is my Teams app. So here you can see is the Cervexa agent. So yeah, I have an issue.
What does Cervexa mean? Just curious, Sayed. Is there a story behind this?
Not a big story, but I think it's like a Gen Z words, right? Yeah, yeah. It's yeah, it's kind of a Gen Z words which are being used. So basically, yeah. Okay, so yeah, as an employee, so the issue which I have is I can't find my last month's payslip. So I've just messaged this agent. So as you can see, the classify agent, based on these details, classified it and its priority. Then the knowledge agent picked it up, and what it did is it searched into our internal knowledge base. So as you can see, I just mentioned payslip. So it knows in which system the payslip should be. So yeah, it's Keka. So that's our HR portal. So as you can see, it suggested some of the uh, workarounds or resolution steps. Yeah, if these 2 suggestions help me, then I can just click this resolve my issue. Then the conversation ends. But yeah, let's assume the issue is still not resolved. So I will click on none of these work. So now the diagnostic agent. So again, based on all the details which have been captured so far, it asks some intelligent questions, like if you are seeing any error, if I was able to download previous month's pay slips, all of those. Then based on that, additional suggestions are given. So these are the different suggestions. So yeah, I can try these options, and yeah, the issue, if the issue is resolved, I can click my issue is resolved. But yeah, let me click on still not working, because here is the best part. So now when we click here, what we do is, so yeah, issue category is not network. So for these things, we create the tickets in Pega. So now what happens is, uh, So Pega's backend API is called DX API. So that returned the UI metadata. Then our Azure function converted it into adaptive card JSON. And as you can see, it's showing the Pega's create case screen directly in Teams. And also, we have already gathered some information, right? So those are already pre-filled. If I want, I can add some of the other optional details. So as you can see, most of the basic UI controls are supported here, like text input, text area, date picker, drop downs. So now I have submitted it. So the case is created and we get the confirmation screen. I think Pega guys might be familiar with this kind of confirmation screen. This case had only one assignment. So after it's submitted, it's routed to appropriate team. But let's say if some other case has back-to-back assignments, then the second form will be displayed here. Okay. So it created the case. So let's go to the Pega portal. Yeah, as you can see, Pega case is created. Yeah, with all the details which we have captured, and it's ready to be picked up by a backend support user. The other important thing is that form which we saw is not static. Okay, to prove it, I'm going to add one new field into that form. Then now later when I run the steps and create a Pega case, that field should be displayed. So as you can see, I have added additional details text area and saved it. So let me go back to the agent. Here I have mentioning other issue.
It's dynamic in nature. So you don't, once you configure it, you don't need to worry. Any new fields are coming automatically come on the adaptive card.
Correct. So we need not make a change in the Azure function or Copilot Studio agent or anything. Just making the change in the backend system is sufficient. So these steps you have seen. So I will skip and go to the create Pega step directly. So here it's creating the Pega case. So let's see if so as you can see, earlier we had only these fields. The newly added field gets displayed automatically. Then as you can see, it's created. So this was for Pega. So same thing, we were able to do it for ServiceNow as well. So for example, for any network issues, we have to create the incidents in ServiceNow. So this. So I have mentioned. I'm unable to connect to Office Wi-Fi. So based on that, issue categories identified. As you can see, it clearly knows what is the Office Wi-Fi name, and it's suggesting the the workarounds or the resolution steps. I will skip this. Then the diagnosis. So as you can see, diagnose agent is asking questions specific to that Wi-Fi or the network issue, not the earlier payroll payslip issues.
I think so. Depending on what the intent is, it is choosing the right agent and it is executing the task, and it is calling a combination of MCP and Azure functions to execute that task, right? So I think this is a great demonstration of how multi-agent systems can work along with the tools and MCPs to resolve or do something on the enterprise level for your own organization, right? So I think great job, Sayed and team, and congratulations for winning the hackathon. And as promised, you presented this in our webinar. Also, this is live in our systems, right? So kudos to your team, right? I wanted to wrap this up. Thanks all for joining. I think today also we had more than 50 people joining. Great discussions around different patterns on agent, sequential, concurrent, group chat based, and Agentic patterns, right? And Karthik was able to code live to show some stuff. I did demonstrate some of the products which we build around these patterns. And again, reiterating, don't go and reinvent your wheel. Know the pattern, and whatever you're trying to build, match that with the pattern and then execute it, right? Um, uh, Keep in mind the complexity, the tokens, the cost in place, because it's just not executing the user stories, but it's also computing how much of performance and cost efficiency you need to bring into your organization, right? Um, with that, I would love to close. We can still leave 4 minutes for questions. If anybody has any questions, we can still wait and answer it. Otherwise, the next session is being led by our CTO Ravi Padwal and Ronald Digny on agentic securing your agentic landscape. We will give a live example using Microsoft as well as Pega in both places on agentic using the control tower as well as the red, green, amber zoning. All right. So 4 more minutes for questions. No questions, then see you in the next call. And thanks, Karthik, and thanks, Syed and Nagraju for organizing this.
Yeah, thank you, Vinit, Karthik, and Sayed for your insights. So hope you all doesn't have any questions. So thank you all for your being part of this today's session. I hope you got enough insights and values. So moving forward, we'll be coming with more sessions and more interactive sessions, I would say. And thank you. Stay tuned.